Welcome to This Explainer. Look, we hear a ton of hype about artificial intelligence these days, right? Usually, it's totally theoretical. You've probably read countless articles promising that AI is going to completely automate infrastructure, operations, DevOps, the whole shebang. But today, we're stepping away from those sanitized theoretical demos and we're diving into a gritty, battle-tested experiment. We're going to explore a fascinating first-hand account of what happens when you stop being cautious and actually wire an AI agent directly into a live Kubernetes cluster. It's a question that probably sends a shiver down the spine of any site reliability engineer. What actually happens when you give an AI agent the keys to your production infrastructure? There's a very real fear here, obviously. The absolute dread of runaway processes, deleted namespaces, and just total chaos. But today, we're contrasting that fear with the audacious reality of testing an AI agent in a live environment, handling organic traffic, with the real potential to break things in genuinely annoying ways. So here's our roadmap for today. We'll start with the Kubernetes AI setup, then look at where the agents shine, talk about what made the operator nervous, cover the essential guardrails for deployment, and finally get to the final verdict. All right, kicking things off with part 1, the Kubernetes AI setup and narrow tool scoping. I want to emphasize right out of the gate that this wasn't some isolated, sterile sandbox. This was a real, mid-sized cluster running a side project with real traffic and real cloud costs attached to it. So the operator didn't just hand over raw kubectl access and hope for the best. Instead, they built a Model Context Protocol, or MCP server, to expose a deliberately narrow set of tools. Notice what the AI absolutely could not do. No applying new configurations, no deleting resources, no arbitrary manifest execution. It had broad read access to inspect the cluster, so tools like get pods, get logs, describe resource, and get events, but its write access was limited to exactly 2 idempotent and reversible verbs, restart deployment and scale deployment. Basically, its mandate was simple: investigate anomalies, fix known safe problems autonomously, and ask for human permission for literally everything else. And this setup wasn't just a random off-the-cuff choice. It was deeply rooted in established security frameworks. By restricting the agent's mandate to investigating anomalies and fixing those known safe problems with a highly limited toolkit, this deployment aligned perfectly with NIST's zero-trust architecture and the OWASP guidelines on preventing excessive agency in large language models. It's the principle of least privilege in action, giving the AI exactly what it needs to be useful and absolutely nothing more. Okay, let's move to part 2, where the agent actually shined, especially with fast investigations. For read-heavy investigations and sifting through vast amounts of cluster state data, the AI agent wasn't just good, it was staggeringly effective. Within the first day, a pod started crash looping. The agent immediately pulled the pod's events, noticed an ImagePullBackOff error, cross-referenced the image tag against the deployment manifest, and correctly hit the nail on the head regarding the root cause. It was a race condition between the CI deployment pipeline and the image build pushing to the registry. For an experienced engineer jumping between terminal tabs, that's what? A solid 5-minute investigation? The AI agent nailed it, along with a clear explanation of its logic in about 20 seconds. 6. This massive number represents the replicas the agent pulled logs from simultaneously during another incident where a service degraded under load. As humans, reading logs across 6 different terminal tabs at once to find a correlation is tedious, and it's super prone to error. The agent did it instantly. It noticed that only 2 of the 6 replicas were throwing connection timeouts. From that, it correctly deduced that the service itself was fine, but a downstream dependency was failing. It held the investigative thread perfectly without getting overwhelmed by the sheer volume of text. But it wasn't just active firefighting where it excelled. The agent proved incredibly useful during routine health checks too. It casually spotted insidious technical debt that usually flies completely under the radar. For instance, it flagged a deployment running with no resource limits, and another where the readiness probe was misconfigured, meaning Kubernetes thought the pod was healthy way before the app could actually serve traffic. Neither of these were emergencies in the moment, sure, but they are exactly the kind of silent killers that never get looked at until they cause a massive 2 a.m. incident. Which brings us to part 3, what made the operator nervous? Or, as I like to call it, the agent's rogue sidekick tendencies. Because, let's be real, it wasn't all smooth sailing. Picture this. You've given the AI the ability to scale up deployments under load. Initially, it worked great during legitimate traffic spikes. But then, a bug in an unrelated service caused a massive retry storm. To the metrics and to the AI agent, this looked exactly like organic traffic. The agent enthusiastically started scaling up deployments to handle the load, completely unaware that it was just throwing more and more compute power at a loop of failing retries. It's that terrifying moment you realize the AI is blindly executing based on surface-level data. So, the absolutely crucial takeaway here is that scaling decisions need real guardrails, not just vibes. The operator quickly realized they had to step in and retroactively apply specific ceilings. They implemented a hard maximum replica count and a rate of change limit. In hindsight, these should have been there from day one. Because when an AI has access to a lever like auto-scaling, it's playing with something that costs real, actual money on your cloud bill. Another nerve-wracking tendency was the AI's habit of over-explaining in a way that totally masked its underconfidence. A few times, the agent presented this beautifully written, highly competent story about a root cause. But upon closer human inspection, it was just the AI's best guess. It was essentially hallucinated rather than something verified by the system. The fix? The operator started forcing the agent to explicitly cite which specific logline or event supported every single claim it made. Once the AI had to point to hard evidence, those vague, overly confident fairy tales dramatically disappeared. We also saw some serious overeagerness with its restart tool. Early on, the AI noticed a pod that was in a not ready yet state. The pod was actually just booting up slowly, but to the AI, it pattern matched a bit too closely to a known crash loop pattern in its instructions, so it just restarted it. Thankfully, restarting a healthy deployment is practically a harmless action, but it was a glaring reminder. Just because something kinda looks like a bad pattern doesn't mean it actually is. This forced the operator to severely narrow the restart criteria and implement a mandatory 10-minute cooldown between restarts on the same deployment. All right, part 4, essential guardrails for safe deployments. If you are a DevOps engineer or an SRE looking to safely implement AI operators, this is your hard-won playbook. This ensures you build in strict limitations before you desperately wish you had them. Step 1, do not start with write access. Run the agent read-only for at least 2 weeks just to watch how it reasons. Step 2, when you do allow writes, restrict them to boring, reversible tools. Restarts, not deletes. Bounded scaling, not unbounded. Step 3, build in a rate limit and a cooldown period on every write action immediately. And step 4, log every single tool call and the AI's reasoning for it. You will find yourself having post-mortem conversations with yourself asking, why on earth did the AI just do that, way more often than you expect? And finally, part 5, the final verdict on this 30-day review. After a 30-day experiment running this AI agent against real infrastructure, the operators summarized the experience beautifully. They said, for read-heavy investigation, it's genuinely faster than I am. For write actions, it's useful exactly to the extent of my discipline around guardrails. I mean, that brilliantly captures the reality of AI in operations right now, doesn't it? It is an unmatched analytical engine for pulling logs and spotting patterns, but its ability to safely alter your environment is completely 100% bound by the human operator's discipline in setting strict architectural boundaries. Which leaves us with one final question for you to consider. Knowing the immense triage speed it offers, but also the strict discipline it requires, are you ready to wire AI into your own infrastructure? Keep these practical lessons in mind when you do. Thank you for joining me for this explainer, and I really hope this dive into real-world AI operations helps you build smarter, safer systems.